First two sections of Unit 9, we talked about the key characteristics of a quadratic function. We talked about how to identify them from a graph, how to identify them given the function itself. And what we're going to do in this section is we are going to focus on how to graph a quadratic function using those key characteristics. So we're going to use the axis of symmetry, we're going to use the vertex, we're going to use the fact that a quadratic is in and of itself symmetric to create the U-shaped graph of a quadratic function, which we call a parabola. Now, it's important to note that you can also graph a quadratic function by rewriting it in vertex form, which is something that we will do in a later section. You can also graph a quadratic using transformations from the parent function, which we're not going to focus on in this video, but in another video. So know that the strategy that we're using today is a very specific strategy based on using the tools that we know so far. And as we build on those tools, we'll talk a little bit further about other strategies for graphing. So a couple of things just to recall and remember. An x-intercept, you can think all the way back to a linear function for that, is the value of the function when y is equal to 0, or it's the point on the x-axis where a function crosses, right? Those are my x-intercepts. They're points on the x-axis. There are other names for these. They are called the zeros of a function, meaning that we actually set the function equal to 0, and those are the x values that make it true. A quadratic, if you think about it visually, if I draw axes here, a quadratic could cross the x-axis twice and have two solutions. It could have the vertex actually be on the x-axis and have one solution. Or it's possible that the parabola is completely above or completely below the x-axis and have no real solutions at all. So these are, again, x-intercepts, zeros, solutions, roots, all words that can be thought of almost interchangeably. Where is the function crossing the x-axis? So to start on graphing, we're actually going to review what we did in the last couple of sections. We are going to first talk about, well, how do we look at an equation and find the axis of symmetry, and how do we look at an equation and find the vertex? Those are going to be our first two steps. So remember, when we're looking at an equation to find the axis of symmetry, we're saying that x is equal to the opposite of b over 2a. And again, remember, this is saying that ax squared plus bx plus c equals 0, or y, or f of x, our standard form of a quadratic. Once we find that axis of symmetry, we're actually going to graph it as a dotted line on our graph. And actually, I should say it's a dotted vertical line on our graph. Then we're going to evaluate, or we're going to use that axis of symmetry to find the vertex, which is going to be an ordered pair. So these four examples that you're going to see, we're going to be looking and going through this entire process, the 7-step process, with all four of these problems, but I'm going to sort of go back and forth between different slides so that there's enough space for us to work through that. So we're going to just start with these first three steps. We're going to find and graph our axis of symmetry. We're going to plug that in to find the vertex, and we're going to graph the vertex. Those three steps. So here's a bigger version of number 1. To find the axis of symmetry, which again we know is the opposite of b over 2 times a, let's identify a, b, and c. A is the number in front of x squared, which is 1. B is the number in front of x, which is -4. There is no c value, so c must be 0. So in this case, x is equal to the opposite of -4, which is 4, over 2 times a. So the axis of symmetry is the line x equals 2, since 4 divided by 2 is 2. We're going to find the axis of symmetry again on number 2. So a is 1, b is 6, c is 2, a, b, c. X equals the opposite of 6 is -6 over 2 times a. So the axis of symmetry, -6 divided by 2 is -3. Why don't you go ahead and pause the video and find the axis of symmetry, identify a, b, and c for number 3. So hopefully you have had time, and hopefully this problem did not trick you. The b value here is going to be 0, since there's no bx term, or no term that it just goes with the x value. There's an x squared term and there's a constant. So x equals the opposite of 0 is 0 over 2 times -1. This is still just 0. So the axis of symmetry is 0. So let's go ahead and go over to our graph and graph those three axes of symmetry. And we're going to graph them as dotted vertical lines on those particular values. So here I have the same three equations, but now connected to a graph. And I'm going to go over to x equals positive 2 here, and I'm going to create a dotted line, a vertical dotted line, as my axis of symmetry. On number 6, I'm going to go to negative 3, x equals negative 3, and create a dotted vertical line. On number 7, I'm going to go to x equals 0, which is also the y-axis, and I'm going to create a dotted line here. So, very first step, find the axis of symmetry and graph it as a dotted line. Now, we're going to go back and find the vertex. So, remember that we just found the x value of each of these vertices. We just found the x value by finding the axis of symmetry. To find the rest of the vertex, to find the y value, we're going to plug in that x value. So y equals, and we're plugging that in up here, 2 squared minus 4 times 2, which is 4 minus 8, which is negative 4. So that's going to be my y value here. If I plug negative 3 in up here, I get negative 3 squared plus 6 times negative 3 plus 2, 9 minus 18 plus 2, which is going to be negative 7. So negative 3, negative 7. Go ahead and pause the video and find the y value of the vertex for number 3. I always love getting to plug in 0. Negative 0 squared plus 4 is still just going to be 4. So now that we found our axis of symmetry and our vertex, we're going to go back to our graph and we're going to plot those vertex points on each of our graphs. And those vertex points should be on the dotted line that we already created. So we just said that the vertex was 2, negative 4 here. So I'm going to go down to negative 4 and I'm going to put my vertex here as best as I can. We said that the vertex on number 6, negative 3, negative 7, so this is 2, 4, 6, 7, negative 3, negative 7, and 0, positive 4. So now we have graphed the axis of symmetry and the vertex for each of these first 3 quadratics. What I want to do now is go back to that step-by-step list and look at what steps 4 through 7 are so that we can finish off in this graph and figure out where to go next. So here we are, back to our steps. What we're going to do now is we're going to create a table, and in the middle of the table, we are going to put our vertex, the point that we found to be the vertex. Then we're going to put 2 points above and 2 points below, and I'm going to show you why, but the moral of the story here is that we're going to actually only have to do half of the work because we can use the fact that a quadratic function is symmetric to finish off our table. Then we're going to graph. We need to make sure that when we graph, we actually cross the x-axis if possible, especially if we're being asked for the solutions. We're going to connect. We're going to make sure that we have arrows on the ends of our quadratic. And if possible, we're going to identify those solutions or the points where we cross the x-axis. So create the table, plot the points, connect with an arrow, identify the solutions as we can. So let's go to the graphs and make those tables. So again, what we're going to do is right in the middle of these tables, we are going to write our vertex. Then we're going to choose 2 points. We're going to go up and down from that x value the same distance. So I'm going to go backwards 1, which would put me at 1. If I go forwards 1, that would put me at 3. I'm going to go backwards 2, that puts me at 0, and forwards 2, that puts me at 4. So I like for my x values to be from lowest to highest, and I intentionally am grouping these together. And you're going to see why I'm using colors in this way in just a minute. So I'm going to do a little scratch work off to the side here, but we are using this function, and we're going to plug in 1. So if I plug in 1, I get 1 squared minus 4 times 1. Well, that's 1 minus 4, which is negative 3. So I'm going to go to my graph. I'm going to graph 1, negative 3. Now remember, parabolas are symmetric. That dotted line is my symmetry, which means whatever is on the left of that dotted line is in the exact same spot on the right, which means I will have another point right here, which means if I plug in +3, I will also get -3. Here's the beauty of symmetry and the reason that we set the table up in this way. What that also means is if I plug in 0 or if I plug in 4, since they're both the same distance away from that dotted line, they're going to give me the same value. So now I want you to ask yourself the question, would you rather plug in 0 or 4? And for me, the answer to that question is always going to be 0. 0 is such a simple number to plug in. If I plug in 0, I get 0 squared, which is 0 minus 4 times 0, which is still 0. So I get 0. So 0, 0, which means that 4, 0 is also a point on my graph, 0, 0, 4, 0. Now, since there is more space on this graph, you should keep going until you run out of space on your graph. Because I'm sort of out of space to show work and my table isn't built to set up more, I'm not going to continue going, but many of your teachers are going to ask that you find the next point until you get all the way off of the graph. What I'm going to do for right now is just connect, make sure that I have arrows on the ends. I can see right now that this is crossing the x-axis, and in fact, it's crossing at 2 points that I have in my table. Those solutions are 0, 0, and 4, 0. And the way that I would like you to write those is using set notation and writing the point on the left first and then the point on the right, because that's how we read. We read left to right. So let's walk through that process again, looking at the next one, -3, -4, and -2, -1, and -5. So -4 and -2, I could plug in either of those to this function here. I'm going to choose to plug in -2. -2 squared is +4, plus 6 times -2, well 6 times -2 is -12, plus 2. This is going to give me -6, so this is -6, and this is -6. So here we go, -6, -6. Then I get to choose between -5 and -1. I'm going to choose -1. -1 squared is 1. 6 times -1 is -6 plus 2. This is going to give me -3. So that's going to put me here. And since I have not yet crossed the axes, I need to find another point. So the next number that I would plug in would be 0, and that would go with -6. If I plug in 0, I'm going to get 2. 0 plus 0 plus 2 is going to be just +2. So 0, 2, and 6, 2. And again, I'm kind of running out of space here, so I'm going to connect. I'm going to make sure I have arrows on the ends. Something to notice, my graph is not perfect, and I can't make the ink on this pen any thicker or thinner. So I can't tell where the solutions are. I can tell that there are 2 real solutions. I can tell that because it definitely crosses the x-axis twice. But since I don't want you to guess, you can just point to the graph. They are whatever these points are, and I know it looks an awful lot like it's crossing at 0, 0, but it's not. It crosses at 0, 2. This is just too thick of a parabola on this little tiny grid. So if it doesn't cross at an integer value, for right now, all we can do is just say, well, there's 2 solutions, and you can tell that they're crossing by showing me where they are crossing. What we're going to learn later in this chapter is that graphing is probably not the best way to find the solutions to a quadratic function, and we're going to spend much of the second half of this unit working on solving quadratics algebraically. Why don't you go ahead and pause this video and first just fill in the tables for the x's. Unpause the video and see if you chose the same numbers. So I would choose 1 and -1, and then I would choose 2 and -2. If you got that, great job, cell 5. Go ahead and choose which of these values you want to plug in and which of these values you want to plug in, and finish off your table. And then unpause your video and see how you did. If I plug in +1, I get the opposite of 1 squared, which is -1. plus 4, which is 3. Remember, the order of operations says that I square this number and then I make it negative afterwards. So this is going to give me 2 points here and here. If I plug in positive 2, 2 squared is 4, then it becomes negative. Negative 4 plus 4 is 0. So I'm going to have 2 points here. I'm going to connect. I'm going to make sure that you can see those arrows on the ends. I'm going to write my solutions, negative 2, 0, positive 2, 0, and wrap that up. Some things to notice. It should make sense that this graph opens downward. It opens downward because there is a negative sign here in front of my x squared term. If you look back at number 5 and number 6, the leading coefficient of that polynomial is positive, which means it should open upward. This opens downward, and that's a really important point to notice, because a lot of algebra mistakes happen on problems like number 7, again, because people incorrectly use the order of operations. So make sure you pay attention to those characteristics. Negative in front means it should be opening downward. So ask yourself on number 8, should it open upward or downward? And it should open upward. Now, what I'm going to challenge you to do is I'm going to challenge you to put everything together here on number 8. I'm going to challenge you to first find the axis of symmetry, to then find the vertex, to graph both of those pieces, to then fill in the rest of your table, connect, and identify the solution. So pause the video, give yourself a solid 5 to 7 minutes to work through this, and then unpause the video and see how you did. So hopefully you did that. Here's the axis of symmetry, x equals negative 1. The opposite of b is negative 2 over 2 times 1. Negative 2 over 2 is negative 1. And then you can go ahead and plug that in to find the vertex. And that vertex is going to be negative 1, 0. So we actually already found our one and only solution. Since this is the vertex, everything else should be going above this point. That's going to be the middle of our table. Then we're going to choose our x values. So our x values have been chosen. Are there other x values you can choose? Absolutely. I would rather plug in 0. If I plug in 0, I get 0 plus 0 plus 1 is 1. So there are 2 points. 0, 1, and negative 2, 1. Choosing between 1 and negative 3, I'm definitely going to choose 1. 1 plus 2 times 1 is 2 plus 1. That's going to give me 4. So negative 3, 4, and 1, 4. Then I'm going to connect and make sure that I have visible arrows on the ends of my graph. And if you haven't already, identify that solution. So we didn't see an example where there weren't any solutions here, but that could happen if we had a quadratic function that was completely above and going upward, or below and going downward. So the key ideas in this section, let's go back and review what we did in this section. The goal of this section was to be able to graph a quadratic function. And how did we do that? We first found the axis of symmetry, the opposite of b over 2a. We then plugged that in to solve for our y value to find our vertex. That's just a review from 9.2. We then graphed both of those things. We graphed a dotted vertical line for the axis of symmetry, and we graphed the vertex point on that axis of symmetry. We then put our vertex in the middle of our table and chose points the same distance away, above and below that vertex, so that we could use the symmetry to have to do less algebra and finding points. We connected the dots, we made sure we had arrows on the ends of our graph, and we identified where the graph crossed the x-axis, which we call the solutions, the roots, the x-intercepts. If you have any questions, go ahead and write them down or comment on this video, and I look forward to supporting you on this. Thanks for listening.